Welcome. In this video, I'm going to show you how to create LoCHaid, low-cost hearing aid device by Dr. Bamla from Georgia Tech University. So before we start, I would like to show you the finished product. So this is the finished product, and as you can see, there are components on both the front and back of the board. Only the 3-volt coin cell battery is on the back of the board. Okay, so let's first go over the materials you need to build LoCHaid. The first thing you need is a 1000 picofarad capacitor from DigiKey, a 15 microfarad capacitor, a 6.8 kilo ohm resistor, a 1 microfarad capacitor, a potentiometer breadboard kit ordered from Amazon, a printed PCB board, a 3-volt coin cell battery, a 20mm coin cell breakout board from Adafruit, an Electret microphone from Adafruit, a stereo amplifier from Adafruit, and a breadboard-friendly headphone jack. Additionally, you should have a soldering iron, I have a digital one, and accompanying solder wire. Now we can finally begin soldering our components onto our PCB. So the first component I soldered was our stereo amplifier, as it is the biggest component and is the hardest to solder onto our board. The stereo amplifier came with little pins with which I could align the part to the PCB, making sure to keep the black part of the pin between the PCB and the part. I began to solder the component to the board. This is a two-step process, and what I like to do is first I solder the pin to our component and then solder the other side of the pin to our PCB. While you're doing this, make sure that the solder at each pin does not touch the solder at any other pin, or else the board will short circuit and become unusable. Once I finished soldering the stereo amplifier, I began to solder the Electret microphone. Since the PCB can become unbalanced at times, I used my breadboard as a stabilizer, but anything that can lift the breadboard off the table will work just fine. After I'd finished soldering the Electret microphone to my PCB, I began to solder the breadboard-friendly headphone jack. The headphone jack is where our wired earbuds will be plugged in, and that is where we can hear the surrounding sound. Next, I soldered the potentiometer. The potentiometer is essentially a knob that can be turned to change resistance and therefore adjust the current of the circuit. In this case, the potentiometer will allow us to control the volume of amplified sound. Now that we're done soldering our major parts to our PCB board, we can now move on to soldering our resistors and capacitors. First, I'm going to solder the two 6.8 kilo ohm resistors to these two spots. The resistor's wires were very long, so I made sure to cut them off with a wire cutter. This step is important as we have to attach our 3-volt coin cell holder to the back of the board at the end. Once that was completed, I soldered a 1 microfarad capacitor to the C2 slot on our PCB. After that, I soldered a 15 microfarad capacitor to the C7 slot on our PCB. Finally, I had to solder two 1000 picofarad capacitors to the C1 and C6 slots. Then I soldered the switch to the 6-hold part of our PCB. The switch makes sure that we can turn on and off our hearing aid device. The final part that we had to solder to our PCB was the 3-volt coin cell battery holder. Make sure that you solder the positive and negative terminals into the correct holes. We can put the battery into our coin cell holder, and now our hearing aid is ready to go. To hear the output from our hearing aid, we simply insert our earbuds into the headphone jack. Our hearing aid device is finally complete. Good luck on making your own low-cost hearing aid device. The PCB files and 3D printed outer covering models will be attached in the comments below.